For my capstone project at Western Governors University's Bachelor of Science in Computer Science, I decided to create a resource to help pre-med students to get more familiarity with the distribution of LCME accredited med schools in the United States. And the reason for that is several-fold. On one hand, I have been an adjunct professor of biology while doing the WGU program, and even after I finished the WGU program, I was still teaching in biology, and I had a ton of pre-med students in my classes who want to become physicians. And I was thinking, okay, there are some good resources out there. Why not create my own, get some practice creating a resource that people really want? Something that people are going to look at and be like, oh, that's actually so nice. So it goes outside the scope of just an assignment, just returning something in. That really appealed to me. Also, I mentioned at the end of my recent video where I talked about an entire recap of my WGU degree, that my own career plans have changed a lot because I had been thinking, okay, I do want to go maybe software engineering and do the UT Austin MSCSO program and go really strong on that front. But for my whole life, I've also loved science, especially biology. And it's only been in the last 2 years where I've really become a lot more interested in health and medicine. All that to say, I have also decided to pursue this path in the medical field, and what I'll be planning on pursuing and submitting applications for soon are MD, PhD programs. So all that to say, my capstone project, when I was finishing it, and now that I've actually just updated it yesterday with some additional information, this not only helps the pre-med students that I was working with and teaching, but also helps me in my own future pursuits as well. So it's win-win for sure. Let me give some context for what's happening in terms of meeting the requirements for the capstone project. So as you know, the capstone project requires WGU students to implement a machine learning algorithm to be able to solve some problem. It can be a business problem. It can be some sort of problem where you do need to have a machine learning solution on a data set. My idea was, why not do something that helps me and all the pre-med students that I work with to get some information about the kinds of med school mission and focus programs. So basically what I mean is, let's say there's some schools that prioritize things like rural health as opposed to urban health, or maybe there's schools that focus a lot on research. I wanted to do a machine learning analysis about those different mission focus groupings and see where the different med schools fall into. How did I do that? Well, I did so through a web app, which I have been screen sharing right now. I'll talk through it as I scroll a little bit. I'm going to go ahead and go top to bottom and continue explaining what's happening here as well. The title of this first map, and really the whole theme of this capstone project, is LCME accredited MD and MD PhD program in the United States. Let me break that down a little bit. What is LCME first off? That's an abbreviation which stands for the Liaison Committee on Medical Education. If a US MD granting school is not LCME accredited, then it really just does not count as a legitimate medical school. People can disagree about that, but really that is at least the perception among legitimate medical schools in the United States. So we have the Liaison Committee on Medical Education. Okay, accredited, they're the ones who are providing this accreditation. So an analog is ABET accreditation is one of the things that accredits the WGU Computer Science Bachelors, which is great. However, even if WGU lacked that accreditation, it would still have accreditation by the Northwest Commission on Colleges and Universities, which is awesome. That's really the one you super need. ABET is just nice to have. LCME is definitely one that a med school needs. Okay, so we have MD and MD PhD programs. MD is a Doctor of Medicine. This is a curriculum where a student goes through coursework and then clinical rotations, culminating in a few different exams like the step 1, step 2. And then once they finish that, they will move on to residency and finally become an attending physician. That is one of 2 paths to do that. There's the Doctor of Medicine degree, which is the MD, and then there's also the DO, which is the Doctor of Osteopathic Medicine. DO programs are very good in their own way. However, MD programs in a lot of ways are statistically, not in my opinion, are better in terms of getting students into competitive residencies. There's personal controversy that sometimes happens where DO students are like, oh no, it's legit as well. Of course, but the MD programs are just better statistically on that front. So I only wanted to focus on MD programs. Among the MD schools, there's a number that offer PhDs as well. This is a Doctor of Philosophy. These are dual degree programs, whereas an MD takes 4 years, MD PhD takes 8 years. And this is the actual program that I want to go for and I plan to submit an application for soon. Finally, this map is showing those kinds of programs in the United States. Great. One thing that I like about this map as I was thinking about how to design it is I wanted it to be interactive so that when a user clicks on any of the markers on the map, it'll take them to a unique page. So let's say I want to look at the University of Utah's medical school. First off, I can say before I even click on it, anytime I hover on any of these map markers, we'll see that there's a bunch of information that may not be helpful to fellow computer scientists, but is really helpful for pre-med students. Things like the full name of the school, whether it has an MD PhD program, the state, city, the accreditation status, the initial year of LCME accreditation. So for example, it can be kind of nice to see that a med school has been accredited for 50 years, 60 years, or even more in some cases. Here we also have the different residency specialties that are the top ranking specialties from the 2025 match. I won't get too much into that, but that can be a nice metric to have as well. Let's go ahead and click on this one. This marker is going to take us to a summary page for the University of Utah's medical school. So it's going to have a quick blurb about the mission and focus, LCME accreditation. If it has an MD PhD program, it will take us to that web page in a new browser tab. So we can go ahead and take a look at that right now. It's saying, okay, this is their program, their MD PhD program, and we can actually go back as well. And if we go to the summary page again, we can go not only to the MD PhD page, but to the main medical school page. This is opening in a new browser tab. And here we can see this is the University of Utah's medical school page. Awesome. We can go back to the map. We can try that again just to give another example. Let's say we want to look at University of, or actually Tufts University. Sure, let's just click on that one. Boom, it'll take us to the summary page there as well. And we can do this several times. Doing this several times will reveal that all 160 of these medical schools have their own dedicated summary page, ready to go. Has a nice little picture just to give some visual context, description about the mission and focus, some additional information, and we can just keep going back to the map as well. So this map, how did I go about creating it? This map is created using Plotly. Plotly is a Python library that enables you to have a bunch of different kinds of data visualization, So you can do things like maps, you can do bar charts, you can do 3D animated plots. It's super powerful. I love Plotly. And to publish it and deploy it to a web application, you need to use Dash, which is another Python library that's really closely tied to Plotly. So I used Dash and Plotly to create this map. The data set itself, I created it manually. I basically went to all 160 medical schools program websites and manually got information from there. I tried initially scraping a lot of this, and scraping definitely works in principle. So for example, you can use a Python library called Beautiful Soup. That's my personal favorite for scraping. There's a lot of other ones like Scrapey, etc. However, I don't think that Beautiful Soup did nearly as good of a job as I did manually because I knew exactly what I wanted it to find. It's tough because as good as a scraping program can be, it doesn't actually think, it just executes your command, right? Whereas humans have that critical thinking to be able to say, okay, is this text really a good representation of what I want to extract? A lot of times, no. So I decided to just create it manually. That took a few days, but it wasn't overly crazy. It was worth the work, and now I'm grateful that the data set's pretty good. Using Dash and Plotly, you can customize every plot really, really well, really highly to the way that you want it to look. In my case, I decided to put these specific pieces of information when I highlight each of the markers, which is cool. You can also click on the legend and you can look at only schools with an MD PhD program if you want. You have a lot of flexibility for how you want to do that. I also included a link to this program, which is a collaboration between the NIH and Oxford and Cambridge in England. This is an MD PhD program where you can do your MD degree at a US institution and then do your PhD at Oxford or Cambridge. So this is helpful for students who are interested in that. If you want to learn more about LCME accreditation, you can do so here as well. These are all links that I manually found and then included in my Python program. Here is another visualization. I should say here that WGU Capstone requires 3 visualizations at least. So the map is my main one up here. And then we also have a bar chart that shows the frequency of med schools in different states. This is nice if someone wants to get a sense of where a lot of these med schools are concentrated. So out of the 160, a lot, about 15, or not about, exactly 15 are in New York, 13 are in California, 13 are in Texas, and then et cetera, et cetera. Some states don't have any. For example, Alaska has 0 LCME accredited MD programs, but Hawaii has a few, or at least 1. Yeah, 1. Puerto Rico also has some, which is cool. This visualization, I won't get too much into it, but essentially this is a summary of the frequency of specialty placement among the top residencies for the 2025 match. Basically, what we can say is that internal medicine was often a top ranking medical residency specialty at all these schools for 2025. And something like pathology was less so. That's already done with 3 visualizations. I actually added a few more because I haven't even gotten to the machine learning aspect of this project yet, which I will talk about now. All that was descriptive, what we looked at earlier. This is going to be more of the non-descriptive, predictive model using machine learning. This is grouping similar medical schools using hierarchical clustering on scikit-learn and SciPy. What on earth does that mean? Basically, as you may know, there are different kinds of machine learning paradigms. So there's supervised machine learning, where you give a data set labeled values, where, for example, let's say you're doing computer vision, you're trying to analyze what kind of order of a bug you're looking at based on a picture. You can feed that algorithm 1,000 pictures of bugs and you can label them like, oh, here's 100 beetles. These are known to be beetles. Here's 100 wasps, et cetera, et cetera. And then using that known labeled data, the supervised learning algorithm will be like, okay, I know for sure that's a beetle. This kind of looks like a beetle. So therefore, I'm going to predict that this is a beetle, stuff like that. There's also unsupervised learning, which is where there's no labeled data. You just want to uncover patterns within the data itself using algorithms that don't know the known truth. That's what I used here, because the whole idea here is that I don't know the labels that we should assign to different groups of medical schools based on their mission and focus. So instead of coming up with arbitrary labels myself or something, I used unsupervised learning to do that and find patterns in the data itself. Specifically, I used unsupervised hierarchical clustering. So you can do clustering in a few different ways. The reason I chose hierarchical clustering is because I didn't know beforehand the number of clusters that I should be looking for. Hierarchical clustering automatically finds a number of clusters for you using the unsupervised algorithm. And to execute that, I used the Python library scikit-learn and scipy. The result was this hierarchical clustering dendrogram, where we have here at the bottom all the different 160 US medical school names. And then above we have the distance between the patterns in their mission and focus statements that I manually extracted, represented as a hierarchical clustering dendrogram. And when we count the number of clusters at a certain distance threshold, the number ends up being 37. So what does that mean? This orange chunk right here is one hierarchical cluster. This green chunk right here is another one. This red, etc., 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 etc. I'll go ahead and open up the actual algorithm that was used to do that. What's nice is that here in this live web app, anyone can go to it. Literally, you can go to it right now. I'll post a link in the description, but you can also type usmedschools.onrender.com. If you want to go to this page, you literally go usmedschoolmap.onrender.com. So it's live, it's not locally hosted, it's ready to go. I'll talk more about the deployment on Render later. So anyways, yeah, you can look at this all now. You can also look at the Jupyter notebook used to do the machine learning algorithm in a binder. And if you do a Jupyter notebook, I highly recommend making it a binder. That way someone can literally look at your whole body of work online without having to install any libraries. Binder is a really nice free platform for doing that. I'm gonna let this build. What we'll realize as we go through it is it's a few different chunks of code. And as you know, you may know what's nice about Jupyter Notebook is that you can break up your code into different chunks to run individually. And you can see, okay, is this cell working well? Is it giving me the data I expect for this next cell? That's awesome, great. So once this does launch, we'll go ahead and take a look as well. Yeah, so it might take a second. And what's nice too is that I'll say now, this is a good time for me to say that you don't have to use hierarchical clustering. You can use any machine learning algorithm you want. It helps if it's under a really common paradigm like supervised learning, unsupervised learning. Those are things that are going to immediately make sense to everyone. You can do really anything you want though, and you really have tons of flexibility for this project. I actually put the Capstone class in S tier on my class tier list video because I just think it's so cool that you can do anything. I chose to do a web app. I chose to deploy it. It's live. Anyone can look at it. You can do a command line tool. Other people have done completely different projects, and that's awesome. It can be in whatever general field you want as well. So you have a ton of flexibility to do it however you really want to. And to be honest, the binder does take a while to launch if it hasn't been launched in a second. I'll go ahead and just let that run for a bit and we'll come back to it. As it runs, before I get to show that code, I'll go ahead and scroll down to this other map, which is going to be a summary of the different hierarchical clusters. Again, the way this is working is these 37 clusters that we see in the legend are these 37 that we see up here in the hierarchical dendrogram. And it's not like they're known or labeled. So for example, it's not like we can label 37, the hierarchical cluster 37 as being the group where they really value diversity, or hierarchical cluster 20 as the ones where they really value research. Instead, we can scroll around and look at the different keywords that characterize that hierarchical cluster. So for example, I'm hovering over University of New Mexico School of Medicine. This belongs in hierarchical cluster 6. And the cluster summary, which is the top 5 keywords that represent that medical school clustering. Those include health, new, care, professionals, scientists. These are some really strong keywords that appeared in the mission and focus statement that I extracted for this goal. We can go look at something different, like we can look at the Renaissance School of Medicine at Stony Brook University. This is in hierarchical cluster 26, and some of the summary words are VP, Stony Brook, Cornell, Presbyterian. Stony Brook being keywords totally makes sense for this. This makes me want to clarify as well. Your machine learning algorithm doesn't necessarily have to give the optimal answer or the correct answer, which sounds kind of weird. The whole idea is for you to get practice implementing a machine learning algorithm and doing something that is at least internally consistent, but it doesn't have to be super robust necessarily. So for example, here, the fact that this is in a cluster Stony Brook isn't that useful. Like, it is definitely true, but it's sort of a tautology, meaning it's inescapably true. It's like saying blue is the color blue. It just, yeah, that's pretty obvious. Or if we look at other clusters, they might not be that helpful. So here's a good example. Washington State University, some of the keywords are medical, college, colleges, Florida program. Washington State University is not in Florida, and for its top keywords to be college and colleges isn't that meaningful for us. However, there is internal coherence, even in this data that isn't perfect. So for example, hierarchical cluster 21, some of the keywords include Texas, East, medicine, school, and communities. What's nice though is that multiple schools in this cluster are in East Texas. For example, University of Texas at Tyler, which I'm hovering over now, is in East Texas. So is Texas A&M University, which is also cluster 21. So there is some internal coherence. I talked about that in the write-up for this course. I'll also scroll, you can see the top part of this table. We have each medical school, so you can scroll through all 160 if you'd like, the cluster they belong to, and then a cluster summary as well. At the bottom of the web page, there's a link to the actual data set, which is live, accessible on GitHub. This is the one I manually created, where the first few columns are things that I manually extracted through Google searches. You can't super easily find the latitude and longitude in a publicly accessible data set, but now you can, because I went ahead and created it. So all this I did manually, and then the only things I didn't do manually were the last two columns. So we can scroll all the way to the right, and we can see these columns, hierarchical cluster, and then cluster summary. These are taken from the machine learning model. And we can go ahead and open up that Jupyter. I think it should be open now. Let's see. Okay, awesome. It did go ahead and open. This is the binder. Again, this is a live web version of the Jupyter Notebook. This is ready to go. Anyone can look at it right now. So this is showing, okay, this is for the Capstone project, grouping similar medical schools using scikit-learn and SciPy. Let me go ahead and drink some water real quick. What's happening here is described here in the summary. So we have the statement that this notebook uses scikit-learn, which is a super popular Python library for machine learning and data science. Highly recommend using scikit-learn for sure. That pre-processes and vectorizes the medical school mission statements that I manually extracted using something called TFID vectorizer. Then it applies hierarchical clustering using SciPy, another Python library, to group similar med schools based on their textual descriptions. Okay, great. Step one, we're going to import the data that I collected myself from my GitHub repository. That link is here. That data set looks like this. I just scrolled over it in GitHub as well. Step two, we're going to convert the text into numerical features, and the vectorization is done here. Step three, we're going to perform hierarchical clustering on the data. This is going to output our hierarchical clustering dendrogram. Step four, assign cluster labels and add to data frame. That's basically adding these last two columns, the hierarchical cluster, and then later it will add the top keywords in that cluster. Step 5 and 6 are really all about getting those keywords. And we can see the top 5 keywords for all 37 clusters here. And then we're gonna add those to the data set. Step 8, that is commented out on this web version because we don't need to save it to CSV. I just did that and I added it. That way they have a record of what I did. This Jupyter can be ran directly in the web browser. So I'll go ahead and run that right now. And we will see that everything works great. So this is running, that ran. And then one thing that can take a second is the clustering dendrogram. So we're at this step right now. In a few seconds, it will go ahead and spit that out. Awesome. So it did. The rest will be done pretty quickly. Yeah, we're done. Great. I hope that was helpful and interesting. Hope this helps some pre-med students as they're looking into programs, and I plan to make a lot more content on that regard. Thanks for watching. Let me know if you have any questions.